It's astounding that a group of people like this can bend the truth so elegantly. And there are people I've worked, like David, for all these years. A subject which is ill-defined, but desperately interesting. And you have to just put your backbone into it and give all you can in that direction, or you'll only slide backward. Oh, sit down for goodness sake. Why am I here? Well, without the Princeton University, without the Neuroscience Institute, and without the Nobel Foundation, I would clearly not be. And I want to thank you to each of these institutions, remarkable in its own age, for nurturing and recognizing my efforts. I have been fortunate to learn from and work with biologists, chemists, electrical engineers, and of course, physicists. Mathematics is essential for it all. I've had exposure both to universities and to places like Battelle, where science is done in a somewhat different fashion. But I'll just remark briefly on the science I've pursued through my career, if I can find any points which haven't already been covered. Princeton saw me as an interesting person to attract from Berkeley as a junior faculty member, and put out the bait, it would be a better teaching environment for me. And in fact, Princeton has been a great teaching environment for me. It's allowed me to develop courses with a few students in them who are not totally afraid of what might take place, and these few students helped define what the course was. And Princeton even stood by me as I wandered outside of my anticipated fields of research, condensed matter physics, and toward biology. And you can see the enormous change which David and I have seen. You look at the biology department in 1980, how many people in it who were teaching in it had majored in physics? Zero, absolutely zero. Negative if you could. And now there's no strong departments that don't have people with that kind of background in science, that kind of ability to face quantitative ideas, and with a pursuit which is no stronger than, but in a somewhat direction from the conventional researchers had been in biology. I think all the things I've worked on have already been talked about by the people here, probably with better knowledge than I now have of what I may have written. But I had started with feeling I wanted to move out of physics, which is interesting, but somehow not quite challenging. This is the kind of physics I had been doing. I wanted to move towards something challenging. And the reason I hadn't gone into biology as younger than that was I didn't understand how to meet this kind of challenge. And as you get older, you begin to say, I ought to understand how research is done in my discipline. And so I worked away at what one might call small problems at the edge, where I could see in the nature of the problem that you could describe the biological situation in physics terms, and you could then make some quantitative statements about the relationship between different experiments. And I worked on a set of smaller problems, electron transfer being one of several. And after a while, I was understanding I'd always been in science since age 4 probably, where I liked to take things apart and understand how they worked. And I was lucky enough to have a mother who had also been educated in physics, and she had an old sewing machine. She said, "You can take it apart all you like. There's a screwdriver in it that allows you to tackle anything in the house as long as you put the screwdriver back." And I begin to understand that if you want to do a big problem, you have to identify it and see how your tools are going to fit on it. And in wandering around looking for bigger problems, I talked with a lot of people. And one of the results of this was I wound up in a position where I could go 3 times a year to several day-long meetings on neuroscience, a meeting populated by wonderful biochemists, physiologists, anatomists, and so on. You can name all the subdisciplines of neurobiology, but it wasn't populated by anybody approaching biology from a theoretical point of view or trying to actually understand how computations could be done on this framework of nerve cells. And there was, in trying to bring these things together, there was an obvious field, and there were no practitioners in it, because none of the almost neurobiologists who were participating in this, none of them really wanted to learn mathematics or physics. And they realized that they just stayed within their own discipline. They weren't going to do anything big enough to talk about how the brain computed, or ambitiously, to talk about what is consciousness. So I was alone for a while, and that helped, because it takes a lot of bumbling to actually get anywhere. And after a while in this, I was beginning to find some people who were interested in this point of view as well. And there was a field began growing up in the United States, certainly, and more broadly in the world, in which you tried to describe computation as it might be done on a set of neurons. I think the speakers who have spoken already here today about what I've done have extended that end of things as far as you possibly can. I have been astonished by what trying to bring physics together with ideas which come from spin, from electronic circuits, coming from different corners of physics, through mathematics, and spit out of the other side some behaviors of activities of multiple cells, the more is different kind of thing, on which you're going to build how neurobiology computes. Well, what should I say? So much has been described already. Let me just describe one more little thing here. The rest is history, as these notes say. I could say much, much more, but coffee calls. I gotta have a short paragraph first. We again face a problem which recurs from time to time, that of creating a technology which threatens its creators. Now we have AI and neural computing. These together are possible examples of original sin, perhaps a global threat to life. In 1973, I was put on a Princeton University recombinant DNA hazard committee as a representative from physics, which had already faced the linkage between the atomic bomb and cheap electricity. This kind of problem is again with us. I worry. But on this happy day, I shall thank you for coming, everybody. Let's party. Coffee.